this. So we have a deck of 64 different cards, and these cards are labeled by 3 attributes: a number, a shape, and a color. The number can be 1, 2, 3, or 4. The shape can be a square, circle, triangle, or pentagon. The color can be red, yellow, green, or blue, and no 2 cards can have the same combination of 3 attributes all at once. The green card labeled with a 1 and a circle is removed. We must compute the number of ways to choose 4 cards from the remaining 63 cards such that for each attribute, either all the cards have the same attribute or all the cards differ in that attribute, and the order of the cards does not matter. That's probably the key thing here. So we're going to consider actually 3 cases, and we're going to do a little bit of just complementary counting naturally because we're removing 1 card from this set. We want to count how many cards, sets of 4 cards can we make from these 64 cards total, and then we'll just subtract however many cards does not have the one that we are going to remove. So for case 1, let's consider 2 attributes same, 1 different. If there are 2 attributes that are the same, then there's actually choose 2 ways to choose the 2 attributes to be the same. And then there's going to be 4 by 4 ways to choose whatever those same attributes will be, since 2 of them are the same. And since 1 of them is different and order doesn't matter, there's only 1 way to do it. If it's where we numbers, it's just 1, 2, 3, 4. If it's shape can be square, circle, triangle, pentagon, it will be in that order. And if you switch the order, it's still the same arrangement of cards. And the same thing you can do with the colors. So you'll get 3 by 4 by 4, and that's 48 different sets for this case. Let's consider a second case. 1 attribute, same, 2 different. Again, same reasoning. There's 3 choose 1 way to have one attribute to be the same. 4 ways to choose whatever that same attribute will be. And then for the 2 different attributes, since order doesn't matter, the key idea to count this part of this case is that, let's say one of the attributes is set in order. So like, let's say the numbers were the same. Choose any number from 1, 2, 3, or 4. Then since, let's say one of them was different, say the shapes, square, circle, triangle, pentagon, in that order. Then the last attribute that's different can be the one that can be arranged. And so the key idea here is that when you're assigning attributes to the same card, the order doesn't matter. But when you're assigning attributes to different cards, they do matter. And so we get 3 by 4 by 4 factorial. This is 24. So this gives us 288 sets in this case. The last case we need to consider, 0 attributes are the same, 3 different. If there's 3 different attributes, then set 1 to be in a set order. So same reasoning as before in case 2. Then there are 4 factorial ways to assign whatever that order of the first attribute you set to the next attribute, and then 4 factorial ways again to assign an order of the final attribute to the previous 2 attributes. So we'll get 4 factorial squared. That's 576. All in all, we just add up the cases. We get 912 sets total. But we remove the green card, 1 circle. Well, note that in all these sets, all the cards are going to occur equal number of times. And since we're only removing 1 card and we're choosing 4 cards from 64 cards, each card will constitute 1/16. Each set will constitute 1/16 of the entire all possible sets. So if we're removing 1 card, that means the total number of sets for the other 63 cards is just 1 minus 1/16 times 912. That's 15 over 16 times 912, and you can just input this in your calculator, and you get 855 sets of 4 cards you can choose from the remaining 63 cards, such that you remove the green card 1 in circle. And we're done.
Hi, everybody. This is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.